Welcome to Mrs. Neller's notes for her pre-calculus class. These are the last section of notes for section 1.5, so it's 1.5 day 3, entitled Equations. And the last two concepts we have to talk about are solving fractional equations and solving radical equations. When you solve a fractional equation, basically what you want to do is get rid of the fraction. So in the previous sections when we talked about finding a common denominator for rational expressions, we still want to do that here. So we're going to find our LCD, our least common denominator. But we're not going to put everything over a common denominator. We're actually going to multiply by the common denominator. That way we'll be able to cancel out the fractions. That way we have a linear equation that we can solve. So if we look at our denominators, we have an x, and then we have an x plus 9. And if we're going to find our common denominator, it would have to be x times x plus 9. So that's what I'm going to multiply each part of this whole equation by. And there's a couple different ways you could write this. You could take the x times the x plus 9 and multiply it by every single part. And that takes a little bit of time, but I think visually it's easier to picture. I'm going to put the 9 over 1. The other way to write it is to just kind of put a big parentheses around the whole equation and then put your terms that you're multiplying by out to the side. And that can be good to do when you're really good at canceling mentally. But if you need a little visual representation of what's happening to each part of the whole equation, do it this way, where you multiply every single term by your common denominator. So now in this first term here, I'm multiplying everything by x times x plus 9. So actually this x in the denominator and this x is going to cancel. So I'll have 10 times x plus 9. No more fraction. And in this second term here, this x plus 9 and this x plus 9 are going to cancel. So then I'm multiplying x times 98. Again, no more fraction. Now in my last term, I don't have a denominator to cancel. The denominator is just 1, so nothing's going to cancel. So I'm going to have the x times the x plus 9 times the 9. But again, no more fraction. Now I do have to distribute here, so I'm going to have 10x plus 90. Here I'll have the 98x. And we could think of this as a couple different ways. I'm going to think of this as a 9x times x plus 9. So remember, this is all multiplication going on between these terms. You can multiply in any order. So I'm just choosing to multiply the 9 and the x first, and then I'm going to distribute that to the x and the plus 9. So I'll actually get 9x squared, and then I'll have an 81x plus 81x. Now, if I'm going to finish solving this, I have to set it all equal to 0. And notice that I have a quadratic term here. I've got this 9x squared. So I want to get everything on this side of the equation, on the right side. Now I have a 10x and a 98x. So that's going to be like a 99x. Okay? So let's think of this. I'm sorry. 98 plus 10 is 108. Okay. So we've got 108x plus 90 is really what's over on this side of the equal sign. Okay. So I'm going to subtract the 108x, and I'm also going to subtract the 90 over. So then I'll end up with 0 equals 9x squared, and then I'm going to have minus 27x minus 90. And to finish solving this, I'm going to factor. And remember, I have a lead coefficient of 9 here. If I look at all my terms, I can take out that 9 as a GCF. So then I'll have x squared minus 3x minus 10. Now that's a lot easier to finish factoring there. Now I need the factors of 10 that are going to get me to 3. So let me continue that work over here. So I'll still have 0 equals 9 times. I'm going to set up my two parentheses with my x and my x. And I would need a 5 and a 2. And I would need the 5 to be negative and the 2 to be positive. So then, remember from our notes from the previous days, I want to use that zero product property. So I'm going to take the x minus 5 and set it equal to 0. And the x plus 2, set it equal to 0. And then I get x equals 5 and x equals negative 2. And again, I'd want to take time and I'd want to check my answers by substituting those values in, make sure that they both work, and they do. Both of those values, if you substitute them back in, will get you a true statement in the original equation. So once you multiply by the common denominator, and once you distribute and combine your like terms, I'm going to set it all equal to 0, and then it'll be like solving an equation like you've seen before. Okay, solving radical equations, that just means that there's a radical in there, and there's a square root or a cube root or whatever. In this case, we have square root. Now, I got to get rid of that square root. But before I can get rid of it, I have to get it by itself. I have to isolate it. So we want to isolate the radical before we square it to get it out of there completely. So to isolate it, that means I've got to get rid of the 2, and then I've got to get rid of this negative or negative 1 that's being multiplied by it. So I've got to subtract the 2 over to the other side. So I'm going to have 2x minus 2 equals negative square root of 6 minus x. And then I've got to divide both sides by that negative 1. I got to go through and change all my signs. So now I have the radical by itself. Now I know there's still stuff inside the radical. That's fine. That doesn't have to be by itself. But I just need the radical to be alone. So I got rid of the 2. I got rid of that negative in front of it. And now I can square both sides. And when I square both sides, I have to square the right side and the left side collectively, not squaring individual terms. Okay, so when I square my radical, that radicand just pops out. And now on the other side, on the left side here, since I've squared this whole group of terms collectively, remember this is like negative 2x plus 2 times negative 2x plus 2. Since I'm squaring it, I'm multiplying it by itself twice. So I'm going to have to distribute. So that's going to get me a 4x squared. And then I'll have a negative 4 and then another negative 4. So that'll be a negative 8x. And then a 2 times 2 is a positive 4 equals 6 minus x. Now again, I've got a quadratic. So I have to get everything over to the left side of the equal sign this time. So I'm going to want to subtract my 6 over and add my x over. Subtracting that 6 and adding that x. So then I'm going to have 4x squared minus 7x minus 2. And it'll all be set equal to 0. So now I have to factor to finish solving this. I'll do that over here. Now I have a lead coefficient of 4. I can't take out any GCFs, so I'm just going to have to leave that lead coefficient. So this is really where our guess and check process comes into play. Let's see, I'm going to need some factors of 4, so let me just try 4x and 1x. And then some factors of 2. Well, that's going to be 1 and 2. And just try 1 and 2. And then this is, remember, where we check our outers and inners to see if we have the right combination. So if I multiply my outers, that would get me to an 8x. If I multiply my inners, that would get me to a 1x. Now I'm trying to get those terms to add up to a negative 7x. And an 8 and a 1 can get me to a negative 7 if I make the 8 negative. So since the 8 needs to be negative, then I need to make this 2 negative, and the 1 has to be positive. So there's my correct combination. So let me rewrite it. I'll have 4x plus 1 times x minus 2. And again, it's still all set equal to 0. And then if I set each of those little factors equal to 0 and solve, I would get x equals negative 1/4 and x equals a positive 2. Now, when you substitute those values back into the original problem, only one of them works. The negative 1/4 is going to be the only value that works when you substitute it back in. When you substitute in the x equals 2, you actually get a 2 times 2, which is a 4. And then inside the radical, you'd have 6 minus 2, which is 4. And the square root of 4 is 2. So then you have 2 minus 2, which is 0. 4 is not equal to 0. So that solution does not work. And since we've been talking about this for 3 days now, here finally is a slide to remind you that sometimes when you're solving equations, you end up with extraneous values. Those are solutions that don't satisfy the original equation. So this is why you have to check your work. You have to check your answers to make sure that you get solutions that satisfy the original equation. So homework tonight is a little bit shorter, but definitely do it. Definitely practice these concepts. And if you have questions, come on in before school and see me.